In this demo, we'll implement classification once again, but this time we'll use the random forest machine learning model in Spark ML. We'll also get introduced to ML pipelines in Spark. Let's get started. We'll instantiate the Spark session as usual and use it to read in our dataset. This time we'll work on adult census data. This dataset contains lots of details about individuals which are collected during the US Census. We want to use this data to predict whether a person earns more or less than $50,000. We read in the data using the Spark session. It's in the CSV format with no header. In addition, every field has a leading white space which we want to ignore. After reading in the data, you can specify the headers and store the result in the dataset variable. Here are all the details that we have about individuals: age, education, the number of years of education, the hours per week that they work, and so on. We'll view a small sample of the dataset by converting it to a pandas data frame. Now, ideally, I wouldn't recommend that you use two pandas. That's because if your dataset is huge, this becomes very inefficient. In our case, though, the dataset itself is not that big. Converting to pandas works here because the formatting is so much better. You can scroll over to the extreme right to see the label column at the very end. Notice that the labels are: the person earns less than $50,000 or greater than $50,000. Of all the columns listed here, the FNL weight is a column that we can drop. This is a very census specific column. This is the weight given to that particular record based on an estimate of the number of people this record represents. This is not really useful for our classification, so I'm going to go ahead and drop this column. Let's observe this data set a little bit. Notice that we have a number of columns with categorical variables, such as the working class and the education of individuals. If you scroll and look around the data set, you'll also find field names which have question marks within them. This data set is missing some values. The missing values are represented as question marks within the data frame. As I had mentioned earlier, the dataset isn't that huge. It contains only around 32,000 entries. Let's clean up this data first. We'll replace all the question marks in the various cells by the none Python value. Here is the same dataset, but this time with none rather than question marks for missing fields. Data frames support a drop NA function, which basically allows you to drop any records which have missing value. The argument how is equal to any basically means that the entire record will be dropped if there is a single missing value within that record. If you perform the count operation on the resulting dataset, you'll see that the number has reduced. Around 2000 rows have been dropped. You can display the dataset. We'll convert it to pandas first for the formatting. Our data seems fairly clean now. You can also use the describe function to get a quick summary of every feature column. Notice some of the columns here: age, the number of years of education, hours per week, capital loss. All of these columns should contain numeric values, but these numeric values are present in the form of strings in this data frame. We can convert all of the values in these columns to numeric types by performing a cast operation. Here we replace the contents of the age column with the same age information but cast as a floating point. If you now view your data frame, you'll find that the values in these columns are numeric. They are floating point values.